Hi guys, in today's video I'm going to be talking about lesson 17 from unit 3, which is called Completing the Square in Complex Solutions. This lesson is going to be on page 121 in your workbooks. Go ahead and open up to that page and we're going to get started. Our goal today is to find complex solutions to quadratic equations by completing the square. I'm going to add to this objective by also saying that we're going to use quadratic formula as well. Okay, so we're going to use completing the square and quadratic formula. Quadratic formula with this is lesson 18, but the topics are so similar, I'm going to be kind of combining some topics with this today. Now, we're going to be finding complex solutions. If you remember the word complex, a complex number is a number that has a real number A and an imaginary number bi, such as 2 plus 3i or 2 plus I root 7, something that has that imaginary piece I within it. We're going to talk today about if we're solving quadratic equations, what situations would have this happen. Also keep in mind that for quadratic equations, we've been talking a lot about quadratic equations and how to solve them. The ways that we can solve quadratic equations are by factoring, by using square roots, by completing the square, or by using quadratic formula. If you are unfamiliar with these last two options, I want you to pause the video and I want you to go back to lesson 16 from last week and review that lesson before we get started today. Let's go ahead and start. We're going to start with our warm-up on page 121. I want you to take a look at the different statements we see here. And I want you to see if you can match the equation in standard form on the left to the factored form in the middle to its solution on the right side. Go ahead and take about 3 minutes to do this. Pause the video and resume when you're ready to go over the answers. Okay, let's go ahead and check our answers. So in matching these all together, there's a couple different ways you could go about matching these. My method is I want to match the factored form to the solution first. Since I know that if two factors multiply to give me 0, then that means that one of them or both of those factors have to equal 0, which means I can easily solve where x in this case equals negative a and negative b. So if I use that idea on this first equation, this would have to give me a solution of positive 5i, and this would give me a solution of negative 5i, which matches the third option. This middle one, if I were to solve, I would get an answer of positive 5 and negative 5, giving me the middle option. And then here I'd get positive root 5 and negative root 5, which is the first option. What may be a little bit harder is how can we take this information and go from the standard form to either the factored or to the solution. You could do this by simply factoring. For example, if I were to factor x squared minus 25 equals 0, I could use a box to do this, where I have x squared and negative 25. X times x is x squared. And then I would want to figure out what two numbers multiply to negative 25 that add to 0 since there's no middle term. That would be 5 and negative 5. And I'm going to test that by multiplying back in. Negative 5x 5x, add to give me 0 x's. 5 times negative 5 is negative 25. So factored, this would be x plus 5 times x minus 5. So I'm going to go ahead and match that first quadratic to the second option. These other ones may be a little bit harder to factor. So another way you can think about solving this, or by figuring out what matches what, is actually solving the equation to see what you get. For example, on x squared minus 5 equals 0, instead of factoring this, I could just solve for x by adding 5 to both sides, and then square rooting to solve. I'm going to get x equals positive or negative root 5, which was the first option over here, which matches the last equation here, which means that option 3 will match this option here. Take a look at your answers and make sure they match. One thing I want you guys to notice as you're looking at what matches here is that problems 1 and 3 are very similar looking to each other. The only difference is that we have positive versus negative. Now look at their corresponding answers. Do those look very similar to each other? Yes. The difference is whether we have imaginary or imaginary or real solutions. All right, I'm going to go ahead and erase the screen and move forward. All right, let's move on to activity 2. Sometimes the solutions aren't real numbers. As we saw in the previous activity, we can have solutions that are real whole numbers. We can have solutions that are real numbers but can't be simplified beyond the root. And we can also have solutions that have i's within them. We're going to solve some quadratic equations. Take a look at these 3 quadratic equations you see here. We're going to figure out what the solutions are to these equations. Now, I want you to take a look at the setup of each one. They're very similarly set up. You should notice that on the left side, we have all of them have x minus 5 squared. So the left is no different from each other. But the right side have different values that they equal. So using what we know about how to solve quadratics, we could easily solve this by using square roots, which means we would square root positive and negative on each side. So let's do that with the first problem. I'm going to square root both sides. The square and the square root will cancel each other out and leave x minus 5 equals plus or minus root 0. Now, what is the square root of 0? That is 0. Is there such a thing as a positive or negative 0? No. So I can actually rewrite this as just x minus 5 equals 0. How would I solve here? Well, I'm going to add 5 to both sides. So x is going to equal positive 5. So in this case, we only had one solution. Is that always going to be the case? No, but in this case it is. Let's move on to the other problem. I want to encourage you here to pause the video and try this on your own, and then resume when you're ready to check your answer. Go ahead and pause the video now. Okay, hopefully you had the opportunity to check your answer for problem 2. I'm going to go ahead and solve. So the first thing I'm going to do, just like before, is I'm going to use square roots on both sides to cancel out the square on the left. That's going to give me x minus 5 equals positive or negative square root of 1. Now the square root of positive 1 is just 1. So that would give me plus or minus 1, which I can then add 5 to both sides. to get x equals 5 plus or minus 1. Now to get you can see that because of that plus or minus, I'm going to have multiple solutions. So x is either going to be 5 plus 1 or 5 minus 1, which means my answers are 6 and 4. You could have also thought about this. I kind of took a longer way around here. As soon as you get to this step, you can split this automatically into two equations by saying x minus 5 equals 1 and x minus 5 equals negative 1. Then when you add 5, you still get 6 and positive 4. So this equation had two solutions. Now, so far for questions 1 and 2, what type of solutions have we had? Okay, on both of these, we've had real solutions. We haven't had to use imaginary or complex numbers yet. So let's take a look at this last problem. On this last problem, we have x minus 5 squared equals negative 1. I want you to go ahead and attempt this problem on your own. Pause the video and then resume when you're ready to check your answer. Go ahead and pause the video now. Hopefully you had the chance to try this problem on your own. I'm going to go ahead and square root both sides. I'm going to get x minus 5 equals plus or minus root negative 1 because the root cancels the square on the left. Now, just like before, I want to figure out what is the square root of negative 1. Well, as we know, there is no real answer to the square root of negative 1. So what we can do is we can use imaginary numbers. The square root of negative 1 is always equal to I. So I'm actually going to get x minus 5 equals plus or minus I. From here, I can go ahead and solve for x. Again, you can choose to either separate right away or separate at the end. I'm going to go ahead and add 5 to both sides so that x equals 5 plus or minus I, or I plus or minus I plus 5. It doesn't matter which one you do. And then I'm going to split this to get x equals 5 plus I, x equals 5 minus I. Now, can I simplify these any more than they already are? No, because I cannot add real numbers to imaginary. So this is my answer for question 3. Again, as I mentioned before, you could have separated at this step to say that x minus 5 equals I and x minus 5 equals negative I. So then when you add 5, you already have your two solutions there. Some people also like to just have their answer with the plus or minus, which in this case I am okay with. So either of these are correct for that last one. So on this last problem, how many solutions did we end up having? We ended up having 2 solutions. But what type of solutions did we have here? We had a complex solution. Why was our solutions complex here when they were real on the previous 2 problems? Well, that all comes down to one part of the equation, the root. Square root of 0 is real. Square root of 1 is real. But the square root of negative 1 is imaginary. Did that stop us from continuing in our problem? No. It just means that instead of 2 real solutions or 1 real solution, we had the complex that we see in question 3. So things that were the same and different between all 3 problems, we saw that on the left side, we have something squared equals a number. What is different is what that number ends up equaling, whether it's a positive or negative value, and whether that gave us real solutions or imaginaries. We're going to go ahead and explore this a little bit further with activity 3, finding complex solutions. So we have these two problems. Now the book wants us on page 122 to solve these by completing the square. And I do want to do that at first, but I will also show you guys how to solve this with quadratic formula. Because if you remember, you can solve these problems using any method. Now these problems cannot be factored. They can only be solved using completing the square or quadratic formula. I'm going to go ahead, let's start with problem 1 on completing the square. Now remember, completing the square is turning the problem into that perfect square that we see on the left, kind of like what we just saw in the previous activity. And we get this factored by looking for by turning it into x squared plus 2ax plus a squared. We try to figure out, based off of the middle number, what does that last number have to be. So let's take a look at this first problem. If you look, we see that our middle number here is -8. So what do I have to what factor of a would result from that -8? Well, remember, perfect squares double on the middle. So half of this is going to be -4. So that means that we're going to have x minus 4 squared on the left. Now, before we write x minus 4 squared, what should this last number be in order to match? Well, the last number is going to be a squared, or -4 squared. -4 squared is 16. This number needs to be 16. So the first thing I'm going to do before we factor is I'm going to add 3 to both sides. Okay, what that's going to do is it's going to give me x squared minus 8x plus 16 equals 3. Now this quadratic we have here on the left follows the pattern of the perfect square. We have x squared plus 2 times the middle number x, 2 times the factor x plus that factor squared. If I double 4, I get 8. If I square 4, I get 16. We can now factor this to that x minus 4 squared, still equaling 3. Now, how does this help us solve? Well, now I can do exactly what we did in the previous activity. I can square root both sides and get x minus 4 equals plus or minus root 3. Now, does the square root of 3 have a nice answer for us? No, I'm going to leave it as a root, which means I'm going to have x equals, let me rewrite that. I'm going to have x minus 4 equals positive root 3, and x minus 4 equals negative root 3. From here, I'm just going to add 4 to both sides, giving me x equals 4 plus or minus root 3, or 4 plus root 3, comma, 4 minus root 3. Now, we have two solutions here, as usual. What type of solutions are these? We have two real solutions here. I have no i's available. No i's shown here. Now, let's go ahead, and before we get to the next problem, let's talk about how would I solve this with quadratic formula. So remember, quadratic formula, x equals, made a mistake here. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, if I were to use the quadratic formula to solve this problem, I'm going to do this in a different color. Then I would have to identify my a, b, and c. A is 1. B is -8. And c is positive 13. And I'm going to plug these values in. X equals negative 8, which would be positive 8, plus or minus the square root of b squared, which is 64, minus 4 times a times c, which is 1 times 13, over 2 times a, which is just 1. I'm going to go ahead and simplify that multiplication, which will give me 64 minus 52 over 2. Now 64 minus 52 is just 12, so it's going to give me 8 plus or minus root 12 over 2. Now the square root of 12 does not simplify nicely for us, so I'm going to leave it and write it as a separated number. So 8 divided by 2 is 4, plus or minus root 12 over 2. And this is my answer. Just like we saw over here, we can split up that plus or minus into a plus answer and a minus answer, or we can keep it together. Even though these answers do look slightly different, they are equivalent. And I could use either of these answers to solve problem 1. It all depends on your preference. Regardless, we were able to see that this had 2 real solutions. Let's see if that is still going to happen on question 2. Take a look at question 2. How is question 2 similar to question 1? You should notice that they both have the same first 2 terms. They both have x squared minus 8x. What's different is that instead of adding 13, we have plus 19. Now, that may not seem like a big deal, but it is going to affect our answer. So just like before, we know that we want this to equal x minus 4 squared. We know that we want it to be minus 4 because half of 8 is 4. Now, in order to get this last number to be 16, the last number squared, we're going to need to subtract 3 on both sides. That will make this equal 16, which means I can factor it, and it will make the right side equal negative 3. Now you might be able to see where the issue will occur. Is when I take the square root of both sides, I'm going to get x minus 4 equals the square root of negative 3. Now, why is that? Sorry, plus or minus root negative 3. Why is that giving us an issue here? Well, the square root of negative 3 is not a real solution. It's imaginary. So remember, how can we rewrite a negative root imaginary? Okay, this is the same thing as negative 1 times 3. And we know that the square root of negative 1 is I. And the square root of 3 will remain. So I can rewrite this as x minus 4 equals plus or minus I root 3, which means that solving, I can add 4 to both sides to get 4 plus or minus I root 3. And again, you can keep this as one answer or separate it if you choose. Were our steps any different from the first problem? Not by much. Okay, our steps are very similar. The only difference is that we had to include the imaginary piece within our answer. We still took all the same other steps. Now, would those steps still apply for quadratic formula? Well, let's see. The only difference for quadratic formula is that c value. It turned from 13 to 19. So if I plug in a, b, and c again, x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. I'm going to get the square root of 64 minus 76. Now, what is 64 minus 76? Well, it's negative 12. Okay, again, square root of 12 can't be simplified. Square root of negative 12 can't be simplified. The only thing we can do further is put an I in to get rid of that negative. giving us 8 plus or minus I root 12 over 2. And then we can separate it into a non-fractional number. There's a lot of work on the page right now. So I want to be clear about our goal when looking at these questions. Okay, our goal is to either use completing the square or a quadratic formula to solve these problems. Now, when solving these problems, our difference from lesson 16 is the only difference is that on problem 2, we had a negative root, which means we have a solution that obtains I. So taking a look at these last 3 problems, this is our synthesis for this activity. I want you to take a look at what we have here. We have 3 very similar questions. All of them are standard form. All of them equal 0. All of them have the same first 2 terms. What's different is the last 2 terms. So we would first have to figure out if we were going to use completing a square here. We'd have to figure out what it's going to turn into when I factor x plus what squared. And again, to figure out this number, we have to take that middle term and divide by 2. All of these have the same middle term, which is 14. 14 divided by 2 is 7. So this would factor into x plus 7 squared, which means that the last term would be 7 squared, which is 49. So that's what we'd have to add to these equations to make it equal 49. Here we'd have to add 5. Here we'd have to add nothing. And here we would have to actually subtract 5. So taking a look, I'll put plus 0. Take a look at these. Which ones do you guys think would have no solutions at all? No real solutions. This last one would have no real solutions. Why? Well, because this will be able to factor, but after I subtract 5, I'm going to have a negative. So when I take the square root, it will give me a negative root. How many solutions will this one have if I add 0? Well, this will just have one real solution. Since the square root of 0, which is what I'm going to have on the right side, is just 0. And this first one will have 2 real solutions. Because after I add 5 to both sides, I'm going to have positive 5 on the right, meaning that the square root would be positive. How would I be able to see that information on quadratic formula? Well, what part of quadratic formula gives me the imaginary numbers? The root part. So if I'm trying to figure out how many solutions this is going to have, all I have to do is do the root part. So on this first one, I would do the square root of b squared minus 4 times a times c. And I would do very similar work, but a different c value on these other ones. Now, I'm not expecting you guys to do this in your head. Quadratic formula is definitely problems that you'd want to have a calculator for. So if I use my calculator on this, if I do 14 squared minus 4 times 1 times 44, I'm going to get 20. So square root of 20. If I do the same thing, 14 squared minus 4 times 1 times 49, I'm going to get the square root of 0. And if I do 14 squared minus 4 times 1 times 54, I'm going to get the square root of negative 20. Okay, which means that in the quadratic formula, I'm going to have a positive root here, which means 2 real. a zero root here, which means one real, and a negative root here, which means no real or two complex. We're going to go ahead and skip activity 4 on page 123, which focuses more on graphs. Let's go ahead and synthesize the lesson together and we can finish this lesson up. So how do we know when imaginary numbers will show up if we're solving a quadratic equation? We talked about a couple of those in the last activity. We would have those imaginary numbers show up when I have negative roots. Now that will happen if I'm completing the square and I get that my perfect square equals a negative number, then we're going to have a complex solution. If I'm doing quadratic formula, and I plug in my work and I get a negative root, then I know I'm going to have no real solutions. So without even having to solve, take a look at this problem here. Okay, I'm actually going to underline it in a brighter color so we can see it better. Without solving, how many solutions do you guys think that would have? Are they real or imaginary? So on that problem, if I were to solve this, it's already factored. So all I would have to do is before I take square roots is get the square by itself, which means add 4 to both sides. Take a look at that number on the right side. Based off of that number, how many solutions am I going to have, and are they going to be real or imaginary? I'm going to have 2 real solutions on there. What about this next one? This is going to give me 2 complex or imaginary solutions. Why are these ones complex? Well, if I wanted to get this first part by itself, I would have to subtract 5 on both sides, giving me x minus 3 squared equals negative 5. And hold up, I got a negative number that I'm going to have to take the square root of. What about this last one? X minus 3 squared equals 0. This one's going to have 1 real solution because if I take the square root, I don't have to subtract or add anything. I would have to take the square root, and the square root of 0 is just 0. Do you guys think it's possible to have only 1 non-real solution? The answer to that is no. If we only have 1 solution, it's because the square root was 0. There is no 0 equivalent for imaginary. We're going to skip the cool down, and we're going to go ahead and finish out this lesson. Again, our goal was to find complex solutions by completing the square, and then there was an additional part, or using quadratic formula, which is the focus of lesson 18, which we are going to skip. So that was your goal today, is essentially the same thing that we learned in lesson 16. I want you to be able to solve quadratic equations using one of these 2 methods. The difference we added is what happens when those solutions end up being complex, which again comes from our negative root. Please shoot me an email if you guys have any questions, and I will answer them the best as I can. We will do the homework for this section tomorrow in class. Have a beautiful day. I'll see you next time.